bit much. And let's see. So this one was a toughie. I did find a simulation. I actually did find one that looks a lot like the real one. And, I really hate the idea of simply having you watch a video and writing numbers down. But also, and then, okay, so we find some kind of sim. Let's see now. Oops. I have to I have it hidden from you. I'll make it alive. And then, I thought I told it to open in a different window. Yes, there, I think so. So let's have a look at this thing. Excuse me. Now, so the idea is that we got a holiday tomorrow, and I want to do something that everybody can participate in, like as in the people tomorrow. And and Miss Dr. Harry likes the idea of having time off too. And so if you take a look at this thing, and so now you're able to go there too. Let's see if I can just squirt it out to you. Ooh, chat window. Somebody already sent me a. Yeah. Oh, Raymond. Yep. We are not going to be here very long at all, I don't think, because I am just going to give you guys a mission and I'm going to turn you loose. And the idea is that we've been getting a little bit more open-ended each time because we've been learning how to do certain things. And so as any good mother or father bird, I wonder if they're like me and being a professor because, the number one reason to be a professor, right? You all remember that, I hope. Let's see if anybody can type it in and remind us what's the number one reason. I mean, there's two main reasons to get a PhD: no dress code and no time clock. What's the number one reason to be a professor? You must have heard me say this. No, you can gather it by the way I treat you. Come on, nobody. Oh, come on, no homework. I have homeworks. I don't have homework. I gave that up. It's the best day of your life. There you go, Raymond. They're right, Jesus. Of course, when you pass that PhD qualifying exam, it's just the worst thing in the world. And in fact, to this day, when I walk in the room at Stony Brook, where I sat for that exam, and it's large, like multi-room space, and we have our holiday parties there. We have ceremonies down there. And every time I walk in that room, I start feeling nervous. And I'm like, what the hell's going on here? And it's like, oh, yeah, this is where I sat for the damn qualifying exam. But once you pass that exam, you're basically never going to have to take another test in your life. So it has some value. And as Raymond has pointed out, because he's in also molecular with me, excuse me, the number one reason to become a professor is to torture young people. What else would you do this job for? It's certainly not for the money. Anyways, or the fame. I don't know. Maybe there's students out there that like being tortured. So they're going to tell everybody how great I was. But anyways, right. So putting everything together. So you got this thing here, and I'll show it to you. Let's see. Fire. And so this one, we already know the answer. So you have some way of measuring heights without, I don't want to give away too much. And let's see, you're able to pause it. Oh, but you can't restart it. Okay, so maybe it's not a good idea to pause it. But you can use this guy, maybe how high it goes. And in this case, it's sort of a quiz. You can read it up there. And you can change things here. And you'll notice different results depending on what goes on here. Okay, so let's so you got that. You can access that on the Canvas homepage, and make one last just double check one more time where you guys could go check. Come on. So once again, I guess we'll have no lab day. Well, no, we did that with the pendulum, right? We had a last week, but no lab day submission this week, but we'll have the final submission. Yeah, so there's the sim, and I published it, so you should be able to see it. So let's go over this now. So our objective today is to study the ballistic pendulum, and then we're going to demonstrate that if somebody told us that that you need to take a measurement with this ballistic pendulum, you can't really prove it because we don't have one to play with, but you can demonstrate to us now because oh yeah, I'm starting to see Christian wants to join my research group. So part of proving to me how worthy he is being my assistant here. So that means I can dump all kinds of work on him and he'll just say, "Thank you, sir." So I'm guessing as part of being a TA or GA, or whatever the hell his title is, he's going to help grade, which would be wonderful. And he'll learn that I've done a lot to streamline the process. But yo,
what kind of research are you doing?
Oh, LIGO gravity waves. I'm an element. I guess maybe you missed our first day. So let's see. Yeah, we said study the pendulum, demonstrate we could use one if we were handed one. And so you've already gotten started on a pre-lab, or you hopefully finished the pre-lab, but it's gotten started on this task. And I was surprised to learn, well, last year or the year before, that they still are used, and they were started being used quite a long time ago. I was surprised by that as well. And it's because for certain of its uses, I would have thought about what you see in Hollywood when they shoot in movies where they shoot bullets into water. Anyways, there it's starting. Oh, I'm not on the front page anymore? Or is this thing rotate around? I'm like a former member or something. This thing is taking its time to load. Okay, and then let's see. So background. So you've already gotten into it, and your background, not to give too much away, but your background should include discussion. Oh, there I'm coming. It's a picture lower down of elastic and inelastic collisions, the conservation of momentum and KE for these two collisions, because we're shooting something into something, right? That's a collision, right? And so then you should be able to apply these conservation rules to the ballistic pendulum. So we got all that background. So what we're going to do is we're going to use that sim here, and you're going to describe it, and you're going to do 3 runs, and you can change the variables each time, and then you'll run it and then write down whatever necessary data, anything you might need. So I'm going to leave that up to you. What should I write down? Okay. Then, for an analysis, we're going to calculate the velocity of the bullet each time. You can check it with the sim if you like. Now, you have to convince me and Christian that you did the work yourself. So you need to be detailed about it. And you need to apply it. Now, part of your background, you can quote the results of last week's lab, right? Because you learned something about collisions last week, didn't you? And once again, this is a collision. Now, for your results, you're going to take each run and you're going to explicitly calculate the momentums and kinetic energies of what's going on there. I suppose we could say before and after. And you're going to show how their behaviors are consistent with the appropriate conservation rule. And so, again, I'm not going to give you detailed instructions on that. You're going to write something up because we want you to write something up and convince us by using your brain and thinking it out and writing it down that you didn't just copy it from somewhere. Don't have to write volumes, but be detailed, be carefully focused, laser focus. A ballistic pendulum is an example of a something collision. And if that's the case, then this should be conserved, that should be conserved, or this should not be conserved, or it will, yes, or it may be or may not. Because because of these conditions, we can use the equations that are associated, see, with that, blah, blah, blah. Okay, so then I have this challenge here, and I was just writing this out. And so I'll just finish it I was trying to make it nice and neat, but we will just have to do it with the pen, write it out here. So this block is 7.75 meters in this dimension. We'll say it's 0.5 meters in this dimension. And let's see, I wrote some stuff down. Where'd it go? Here we go. We'll say that L equals 10 meters. We'll say that this is a cannonball. And it's, of course, headed in this direction. And we're going to say that the mass of the cannonball equals 10 kilograms. And that the velocity of the cannonball equals 10 meters per second. And the mass of the block equals 1,000 kilograms. And you can, let's see, insert shapes. Let's see how this works. Oh, I guess that works okay. I was going to make it dotted lines. You can assume that the cannonball magically appears, which is kind of what any calculations you've done or examples you've seen, they don't actually say it that way, in the center of the block. And let's see. Oh yeah. So you say the mass of the arm here, and let's say the mass of the arm is equal to 0.0 kilograms. So you can ignore the mass. Okay. So the challenge is now to write this all out and say, okay, what is theta? The angle here, very similar to the pre-lab at at its furthest extreme, theta of furthest pivot. And so you'll write out an analysis, and you'll I've built into this thing some subtleties. So the more subtleties you pick up, the better you'll do when we look at it. All right. So let me save this here, and I will make a PDF out of it, and I'll post it, but I'll give it to you guys. Anybody else have any questions?
Yes, I
The
have a
rest
question.
of us. Okay.
I just want to confirm that our final submission is just doing this challenge problem and including lots of analysis, right?
Well, the write-up, right?
But for this challenge problem that you just put on a minute ago, right?
Well, no, I mean this whole thing, right? You got to write up do the whole lab in your logbook,
Okay.
of course.
So just the lab manual that they sell in the school store, we're just using that one, right?
No, we are not. We don't have that equipment.
We don't have a lab manual?
We don't have a lab manual for this lab, no, because we don't have a ballistic pendulum. We have all this background. We have this sim that I just showed you. And I gave you the task of here. And then there's the analysis and the result. And then you go on to write up this.
If you need help, still reach out to us.
Ooh, that was really garbled. Well, Christian, I think.
Oh, yeah, sorry. No, I said if you need help, just feel free to reach out to us.
Yeah, there's Christian as well to talk to. But in this case, this is sort of like we want the fledglings to spread their wings and fly on this one. But yeah, this is I thought I was pretty explicit here. You have your objective, the background you've already been working on, and just to make sure your background should include all this, then you're going to use a sim and you're going to use your analysis framework that you developed in the pre-lab and whatever else you need if you didn't get it all. And then you're going to apply that to this sim, and you're going to find out what's the initial velocity of the bullet each time. And that's here. And then I'm asking you to do an analysis of the momentums and kinetic energies of the participating objects, and then how they all obey their conservation. How they obey their conservation rules. And then as a final thing, to take this problem using the framework once again and find out what's the pivot, why the theta at the end, what's the angle, and all the steps that you took to get it. That's it. That's the lab.
Okay, so I'm just running this sim 3 times and then applying that information to this challenge problem.
That's it in a nutshell. That's right.
Okay, thank you.
You're welcome. Anything else? All right.